Can you see the slides?
Yes, sir.
Yes. Okay. So we'll go back to what we were doing. I don't think we'll need to write anything. If necessary, I will try and give this piece of paper another shot. Okay. The problem is the guy who handles this also doesn't really know it much. So anything that goes beyond basic these things doesn't work. He goes into the ground floor and calls somebody and so on. That's a lot of disturbance. So anyway, so this is where we were in the last class. We were talking about DHCP, and as I said, that DHCP we primarily use to get IP parameters, IP, subnet mask, gateway address, and DNS server addresses. Okay, but DHCP can give you can configure a DHCP server to give out a lot more parameters if you want. Now, typically in your desktop laptops that you see around you, we get mostly this for four things: IP, subnet, gateway, and DNS. But you should know that you can give almost anything that you want, any network parameter that you want, or even non-network parameter like boot file server, boot file name, and so on, time server, etc. if you want through DHCP. Runs on UDP, client on UDP port 68. So this is one thing that I said is kind of different. Normally we specify the server's IP and port, the client port can be anything. But for this one, the client port is fixed. Okay, we'll see a little bit why. Motivation was kind of clear. Just to recapitulate, you want to move a machine between networks, which means if you move one machine from one subnet to another subnet, your IP, subnet, everything changes basically. So if you move it, it should be automatic. You should not have to manually configure anything if you don't have to. When you add a new machine, you should just plug it in, connect to the wireless or plug it in a wired LAN and so on, and everything should work. Normally, you should not have to do anything. Then this reclaim unused IP address space. So it's a lot of places. I told you one example. Even in office spaces, in meeting rooms and all, you go, you connect your laptop, and you expect to connect to the network. But then through DHCP, you get an IP address, and then you go off. But then that IP address is still on your machine. It will stay on your machine for a little bit time. We'll see till how long. Okay, you can configure that also. But then you should not, have to kind of forfeit that IP forever, basically, because the DHCP server has given you that IP. It does not know necessarily that you have moved off. It's not going to ping you every time to say, do you have the IP? Are you still using the IP? And so on. So we'll see how that is done. So the next person coming into the meeting room, after some time at least, should be able to get that same IP. In all these cases, your configuration should be simple and automatic. The user should not have to do anything. And by saying that should not have to do anything, should not have to do anything, DHCP is giving you these things. The user should not have to even know the address of the DHCP server. But that's also a configuration. You should be able to just plug in connect your computer, and everything should work automatically. That's the purpose of using DHCP. So, what are the three types of addresses in DHCP? So this middle one is what you guys get. This is the most common thing. So I'll come to the second, first and third ones later. Okay. So dynamic allocation. So when you get an IP address from a DHCP server, you get it for a specific time. It's called the lease time. So it's the responsibility of the client, which means your laptop, desktop, the DHCP client running on your machine, to renew that lease before it runs out. So that's how the DHCP server will reclaim the unused address space. So think about the meeting room scenario. You walk into a meeting room, they will give you I can configure that in the DHCP server. Say I give you a lease for 12 hours. Okay. At the end of 12 hours, your meeting is over, you walked off. So a machine cannot renew its lease anymore. It cannot connect to the DHCP server. It's on somewhere separate. So the DHCP server at the end of 12 hours will find that you have not renewed your life IP. Take that back. Next person comes in. next day meeting, we'll get that same IP. Okay. Now that 12 hours is just an example. Typically for your laptops, desktops, we give in days because typically you are going to use it more often. Okay. But then, as I said, in the meeting, you know what's the expected use is not going to be too long, so give in hours probably. So IP address given to host for specific time, this is called the lease time. Client host can relinquish before that time or renew. Actually, this is wrong. This is not renew after that time. You have to renew before the lease expires. Okay. And this is the most common allocation method. Okay, so online people, you can hear me so far clearly?
Yes, sir.
Yes, sir.
Okay, good. Okay. Now, other than that, you have these two things. Automatic allocation. Keep track of what is given to what. Okay. If I give you something and I want to keep track of it, I need a primary ID for it. That ID can be, for example, your roll number. This cannot be unique ID. So I say this roll number has been allocated this seat. Okay. And therefore this seat cannot be given to anybody else. For a machine, what DHCP uses, the primary ID is the MAC address. So which basically means that if you have more than one network interface, okay, you have to ask for DHCP for its IP for each of them. Because remember, MAC ID is with the network interface. It's not a machine thing. The machine may have more than one interface. Okay. So the primary ID, so kind of think of DHCP keeps a file. MAC ID this, IP address allocated this, MAC ID this, IP address allocated this, and so on. So when it dynamically allocates, it updates correctly. Okay. Now, I can configure the DHCP server to say this MAC ID will always get this IP address. And it's permanent. Okay. Now, why would I want to do that? Just I was talking to somebody in class yesterday. So just think that you are running a server. So the server's IP has to be fixed. It has to be known to the world that this is the IP. Okay. Now that's an IP you cannot change. You do not want a situation where just because, just think with me, your lease time was, let's say, 3 days. So your server was expected to renew the IP before 3 days. But for some reason the server was down. Or it could not connect to the DHCP server for whatever. Your network was down, whatever. So somehow it was not able to renew its lease within the 3-day expiry time. Then everything becomes normal again. It starts up again. And now it contacts the DHCP because it does not have an IP. Now it should get back the same IP. Because if it gets a new different IP, then the rest of the world will not be able to connect to the server. Server IPs have to be fixed, as you have seen in your labs also. Okay. So I can do this automatic allocation. It's a permanent address given to a host. So that IP will not be given to anybody else, and DHCP will mark in its configuration files saying this MAC address permanently allocated to this IP. So if this does not want it, I will not give it to anybody else. But whenever this wants it, this is the IP feature. Okay. So you always, that machine will always get, that network interface will always get that. And this is, as I said, is required when you need to have a fixed IP for some machine forever, basically. Manual is kind of a type of automatic. You can allocate it, allocated by administrator specified in a file. All of these are specified in a file actually. Okay. So DHCP only conveys that information. So it's a form of automatic also. So automatic is permanent, manual is not necessarily permanent. I can configure this. So to summarize once again, the most common thing that we will see is this dynamic, okay, which is given for some time to you. If your machine does not renew it within that time, it will be taken back by the DHCP server, given to somebody else. And this is in the cases where what IP your machine gets does not matter as long as it gets an IP to connect to the network. Whereas automatic is basically when I'm running servers and so on, so I want one fixed IP for the machine at all times. Okay. So this is where we were at the end of last class. So kind of the sequence of messages that DHCP sends. So first we look at each of these messages in a little bit more detail. So client sends a DHCP discover. Remember, you have kind of think of a situation where you have kind of just connected a new machine into the network. So it has no network information. What happens on renewal? Things will be easier actually. We'll see. Okay. So it doesn't even know where the DHCP server is. So it'll send what is called a DHCP discover message. We have seen that it can be sent with broadcast IP. I'll talk about that again in the next slides. Now this message will reach all DHCP servers on the subnet. So just think of one subnet for now. Okay? Because remember, when I broadcast a message, the message will go to all machines only in the subnet. The gateway will not forward it beyond the subnet. Okay? So just focus on one subnet now. It has reached all DHCP servers in that subnet. Now, each DHCP server does not know what the other DHCP server is going to do. Because it is possible that for one DHCP server, the way I have configured it, all its IPs are already given out. So it's not going to respond. It has no IPs to give. Okay? So, because they don't know who else is doing what, all the DHCP servers are going to respond to this DHCP discover message by giving a DHCP offer, if they can. Okay? And in a very high level, this is going to say, okay, I can offer you this IP, this subnet mark, this gateway. Okay? So, again, this will come to the client. We'll see a little bit how. Now, the client will wait for some time, look at all the DHCP offers that has come, pick one of them according to some policy, okay? And now we'll request that particular DHCP server to say that now I'm committing, please give me that. Now this will be broadcast again. So all the other DHCP servers which has offered will hear this. Then we filled in the message to say which DHCP server the client has chosen. So they will back off. The client has not chosen me, so I don't need to participate anymore. I can free up that IP, give it to somebody else. Okay. And that one DHCP server which gets the DHCP offer meant for it will now say, it was an offer saying tentatively I can give it, do you want it? Now the offer is saying basically, the request is saying yes, I want it. She's going to make it permanent. I don't mean permanent, it's going to come in. Saying that for the next 3 days this is given to this. Okay? And then it says, gives an act telling the other guy, the client, that I made it permanent. And as far as the DHCP server is concerned, that is kind of the last message it waits to hear. It has kind of to it says that this IP is now given to this MAC address for the next 3 days, let's say. Now for whatever reason, there is still a chance for the client to not accept it if it finds some problem. Usually, as I said, this happens because of misconfigurations in DHCP server. Somehow a server gave an IP that is already in use. Should not happen, but somehow you configure things wrong. Okay? So the server side, the client still finds any problem with it, okay? The client will send a NAC and not accept that thing. And they'll start the DHCP discover message. Okay? Send a DHCP decline. Okay? But see, the server is not waiting to hear the DHCP decline. To the server, either it has been able to give, in which case it has sent DHCP act, or it is not able to give. As we discussed yesterday, one simple scenario where it is not able to give is more than one client requested it, it offered the same IP to both, kind of offer, because both of them may not take it from. Now that the request came, it has given to the first request. The second request has come, it has offered the same IP, it cannot give it anymore, it will send a DHCP NAC. Okay? But after that, as far as the server is concerned, it is given or forgotten. But the client has another chance to check it again. If it still doesn't want it, it can send a DHCP decline. Note that these are all happening over UDP. Okay, so one good way to think about it, what happens if any of these messages get lost in the middle? There's always a timeout. Okay, so if your DHCP decline gets lost, what will happen? Anyone? Offline, online? So the server has sent a DHCP ACK, which means the server has committed. It has written in its database that this IP is given to this MAC address. The client does not want it for some reason. It has sent a DHCP decline and it is lost. But the client thinks I have sent a DHCP decline. Because there is nothing in response to a DHCP decline. That's the last message in the exchange basically. So what will happen? What? Right. So as someone noted, basically, so the server will still think the IP is given. The client does not want it, so client will start the DHCP discover again. Because it has not got the IP. But the server will keep that IP kind of reserved for this because it does not know. But then again you have given it for just a lease time. So it's not used or it's kind of wasted only for that lease time. This client will not renew it from that server, so it will just go off again after some time. Okay, but you should think for each of these steps, what happens if the message is lost? If you are expecting something, okay, you can time it. So if a server has given a DHCP offer, it expects a DHCP request back. If that does not come within a timeout, you assume that this client does not want it. So just give it off to somebody else.
After this has happened, will the client send DHCP discover again?
Okay, so the question is that after the DHCP, if the DHCP decline is lost, okay, now the client has not got its IP. Will the client start the DHCP discover again? Yes.
And if it does the DHCP server give it its IP?
Okay, good question. So what happens, because once it does the DHCP discover, it will go to the same one. Okay, that you can configure things. So what is going to happen? That this DHCP server will figure out that there is already an entry for it. Okay, with the least time output. Okay, so it's just going to be ignored. One possibility. So you can configure that basically. Okay, yeah.
Just give it back again. This is a scenario like a machine switched off for 1 hour and switched back.
Yes and no. So the other possibility that came is what if, so again think of the scenario, DHCP decline got lost. The client sends a DHCP discover again. Let's say that server was the only server in there. Okay, it reaches there. Okay, so now the server can give that again. That is a policy. And if the server gives that again, you may run into the problem immediately that you do not know why, what's the reason for the client not getting. Okay, the server usually, as you said rightly, you can configure it, will give that again. The reason being the server does not know whether the client has sent the DHCP decline and lost, or whether the client has not received the DHCP ACK at all. Because if the client times out waiting for the DHCP ACK, it also thinks the server is not ready to give it to it. In any of those cases, the client has not got the IP, so it will start from the DHCP discovery. Okay, online people, is it clear? Can you hear me first of all?
Yes, sir.
Okay. And this last bullet is something, is the audio any different now? Because I just realized that both my mics were on. Is it clear now? Online?
Yes, sir.
Okay. All right. And the last bullet is not part of this getting the process, but once you have got the thing, okay, you can release it anytime for whatever reason. You are, booting something. It's a configuration of the client side to say that I don't want it after this much time. You can configure many things. If you don't want, it's just a good thing to do, nice thing to do for the DHCP client. You say release the address. lots of time, it's not just a nice thing when we want to detect problems, okay? So we kind of release and renew, okay? So normal renew will give you the same IP. A release and renew may give you a different IP. So for some reason you have an IP conflict or something, you just want to forcibly release things, okay? Wait for some time and then renew it again. So you get a different IP that's not in conflict with the other used IPs. Okay? Yeah.
We're talking about problems like giving the same IP to two different machines.
Right.
How is that detected? And who will accept it?
Okay. So it's a good question. The question is that if two machines get the same IP, okay, how is that detected basically? Okay. It's a good question. I will find out. I can see the problems. I think the way DHCP, I'll confirm to you, okay, is that you ping with that address and you see if somebody responds in your subnet or not. If it responds basically, then you know that somebody else is using the IP address.
I mean, in the first place, how did the problem actually happen? Like, how did the
Okay, IP address conflicts usually happen because of misconfiguration. The question is, how can two machines get two different IPs? Okay. If you have DHCP properly configured, it should never happen. Okay. But here is a stupid way that we see it happening all the time. So you see, if I get a subnet with let's say 128 addresses, okay, as I said, some machines in there will also make static addresses, IPs. So the good way to do it, so just think about this scenario, everyone. You have 100 addresses at your disposal. You are running 10 servers in your system, and the other 90 are client machines. So those 10 machines needs the IP which are fixed. The 90 machine IPs can be anything. So the good way to do it is to do everything through DHCP. But for those 10 machines, do an automatic allocation. That means in the configuration file for those 10 MAC addresses, I put permanent IP addresses. They will also go to DHCP, they will also get the address, but they will always get the same address. And the 90 others I will put in a dynamic address pool. Okay? But here is routinely what people do. You needed to run a server, you don't contact your administrator to actually, because the administrator can only is in the DHCP server side. Okay, can change that thread. You say, I'll just use a static IP. It's very easy to find your subnet. Okay. So most of the time when we see IP address conflict, what I have seen is because somebody stupid has configured a static IP, not knowing that there is a DHCP pool running in the background is conflicting. Okay. Sometimes it happens because of bad misconfiguration of the DHCP servers when you have more than one server in a subnet. But usually always misconfiguration on the DHCP administrator side or misconfiguration on the client side. In a proper system, it should never happen. I'll get back to you on the answer of that. I think DHCP does it by just checking with ping and so on. I'll check. Okay, so let's look at the basic things. Each of these things in a little bit more detail. So client will broadcast the DHCP discover. As I said, it's like I have a network. I want to find out something. I do not know where it is. So only way I can do is kind of broadcast to everybody saying, does anybody has this? Okay. And this is beyond DHCP. This is the kind of this flooding that you have seen and so on. Flooding is just one way of broadcasting. Okay. Anywhere, anytime you start off with no information and you want some information that may be in your network, you broadcast. Question is, what is the mechanism of broadcast that is available to you? Either you have broadcast IPs, etc., MAC and so on, or you have flooding, etc., it's the arbitrary topology and so on. Okay. So you use all once as your destination IP, which is a limited broadcast IP, as I said. It will only broadcast within the subnet. Source IP is set to all 0, which is basically this machine. And I send the client's MAC ID in message for identification because that's the primary ID, like your roll number. Okay. And these are option. Client can request a specific IP and specific lease map. It doesn't mean it will be given, but I can tell the client that I want this IP and this. Now, why will it want that? Depends on many things. As I said, you have forgotten to renew, because at that time, not forgotten, the time for renewal, your machine was down. Now you are a client machine, I agree, you don't really care what the IP is. For whatever reason you have stored the previous IP, you said, I had that IP, please give it to me. Okay. Lease time also you can request, these are all options. Client can specify a preferred DHCP server. Again, that same scenario. If you have a perfectly new client, the client does not know anything about DHCP servers. But again, think of a scenario where you were connected to a DHCP server, you were supposed to renew, but you could not renew for some reason. Now you have rebooted again after some maintenance or something, but you have stored the DHCP server address. Okay. So now you can ask, you can have a field in your message specifying that this is the DHCP server I want. Okay. And it can specify what parameters. As I said, DHCP can give you many different parameters. You say which are the ones that you want. So for our case, we will say IP address, subnet mask gateway, primary DNS server, secondary DNS server. Okay. Actually, 2 DNS servers. So when the DHCP servers receive this, as we noted, all DHCP servers on the subnet will receive. Okay. Well, not necessarily so. Some may get lost also, depending on how the subnet is configured and so on. Okay. So for some reason, on your subnet, one of the switches may be down at that time. Okay, one of the switches had very heavy traffic and the packet got dropped in the ports. So it's not necessary that just because you broadcast, remember these are all UDP, that all the DHCP servers, or even at least one of them will even get it. So it is possible the client sent a DHCP discover and nobody gets it. But then, again, like any other UDP based protocol, the client will then time out, waiting for a DHCP offer, and then just broadcast the DHCP discover. Okay. And there are easy ways of checking it. Okay. I'll tell you a couple of commands at the end of the class by which you can release your IP and then renew it. So you release your IP, disconnect your laptop, and then do renew. That means you are not reaching, you kind of emulating basically that it's not there, basically, that the server is not there. And you can see what happens. So I'll tell you the commands at the end. Okay. Once the server receives the DHCP discover, we'll look at the IP pool given to it, we'll allocate an IP for it. We'll try to allocate the IP requested by client if possible. Now that's all as per policy. You can configure it. So when the way I've written it, it means that we'll always try to allocate the IP requested by if possible. I can set a policy which says, kind of completely ignore that request. I will allocate as per my policy. And then you dynamically allocate one, otherwise from the pool of available IPs. Okay? So this is what is called the DHCP pool. From the DHCP server, the set of IPs it can give is termed the DHCP pool. Lease time, again same thing, you can set it to what the client has requested, subject to local policy, or there is a default that you have. Okay? You select the parameters requested by client. Or there is a default set, again, if the client has not said anything. Okay? So typically, as I said, IP, subnet and gateway are the 3 default things that will always give. Alright? And then the DHCP message, I'll show you the format. I don't expect you to read it for the exam, but just to show you, okay, just in a couple of slides, we'll put all those information in the response message and then we'll send it back to this. But as we said, this is offer, this is not a final commit. The client has to send a DHCP request to accept that offer. Okay, it's just temporarily I have reserved this for you. Message is either, so now how do I get back that message to the client? Because to the server was easy. I broadcasted, everybody got it. Okay. Now there's a little bit detail there also. When I broadcasted, all it means was that it reached the IP layer of everyone. Now what does the IP layer see? It sees it's a UDP protocol. This goes to the UDP software. The UDP software sees is port 67, gives it to the software running on port 67. Port 67 is my DHCP server, basically. So it reaches the DHCP server. Okay. Because see, it reaches the IP layer of everybody. It reaches the UDP layer also of everybody. But then all the other machines which are not DHCP servers will not have anything running on port 67. And what will happen then? Anyone? Offline, online? So think of this broadcast message that has reached a machine that is not the DHCP server. It will reach, it's a broadcast IP. Okay? Then the IP will see the protocol field is UDP. So it will be given to UDP. UDP will find that it's not 67, nobody is fine. What will happen?
Destination and reach.
Huh?
Destination and reach.
Okay, very good. So the answer is, so it will be dropped first of all. But when it gets dropped, it's actually an IP packet that will drop because of that the port was unreachable. So an ICMP will get sent back with type field destination unreachable and the code field which further says why is the destination unreachable as port unreachable. Basically. Okay? But anyway, that's a digression from DHCP. Okay. And then the server will send a DHCP offer. So how will I send that back? Because remember, when I send the DHCP discover, I send this source IP all 0. You cannot send a message to all 0. Okay. Now, there are two possibilities. Okay. I can send it with a broadcast IP path. What will happen? It will reach the IP layer of all machines, including the client. Okay, but there is a catch there. But just think with me. Okay, now the server has sent a DHCP offer back with destination IP equal to all ones. Source IP will be the server side. Okay, it will reach the IP layer of all machines, including the client. Okay, what will all the machines do? It's the UDP packet, give it to UDP layer. What is the port number? You see, because when it came, it didn't come with any, that's why I put that particular 68 port number. Because now it will be given to 68 port number. This is a well-known port, so no other client should be using it for anything. That's how one way it will reach back to the client. Are you with me? Online?
Yes.
Okay. You can hear me with no problem so far, right?
No,
Yes,
sir.
sir.
No.
Okay, good. All right. Yeah. Question. So the question is, if multiple clients are expecting a DHCP offer, this offer goes to all of them. Okay. That's what the format of the DHCP message comes in. There will be a field in there to identify who is this offer for basically. So give me some time, I'll show you that format basically. Okay. You will actually have a transaction ID to match request with responses and so on. Not transaction, I'll see. I'll have the format. Okay. That's a good question. Alright. But there is a small catch here. Okay. Depending on the implementation, remember that I am assuming when I say this mechanism will work, that the IP layer is configured properly. Okay, and IP layer is ready to accept packets even though it does not have an IP address of its own. Okay. Now it will depend on the implementations. Some clients are ready to accept broadcast IPs even before the IP layer is fully configured. Some clients are not. So there will be a flag in the message where the client will say, am I allowed to, or am I able to accept broadcast IPs or not? When it sends the DHCP discovery. If that flag is set, then the server can know that that client can accept broadcast IP. It does not got a unicast IP, but it can accept the broadcast IP. Okay. But what if not? So now suppose the client says that I am not able to accept a broadcast IP because I cannot accept any IP because my IP is not configured. right? This case, so it cannot send a message with broadcast IP because the client will ignore it. Others who are configured will take it, but then they will not have anything running, or they will detect that it's not for me. But the client for which it's actually meant does not have an IP address, which says, I'm not able to accept broadcast IPs unless my layer is completely configured. How can you send the DHCP offer back? So what did you know when the DHCP discover message went? What does the server now know about the client? Very good. So when the DHCP discover message went, the server knows the MAC address of the client, because the client has put that in the DHCP message, okay, not in the IP header or anything, okay, out there. Okay. And it's also in the Ethernet header, but Ethernet header is skipped off before it went to the UDP header. So you don't have the Ethernet header. But it will be one field in your DHCP message. Okay. So now you can send it through the Ethernet layer with the protocol field set to IP, and then create a packet which will be now forwarded back. You have to have something. You cannot say I will not accept anything in return. Then it cannot get to it. Okay. But for some reason, if you cannot accept the broadcast IP, most of them do. Okay. If you cannot accept it, you can just send it to Ethernet layer. So it gets accepted there, others drop it, and then it gets passed on out. Kind of the same processing, okay, but then not directly the IP processing basically. So a little bit confusing, but I will keep it at that because there is some more fields involved in it. So the message is either unicast to the hardware address of client, which the server knows, or broadcast. The client should specify broadcast in any message to server if it cannot handle unicast before TCP/IP configuration. Oh, I'm sorry, it's the other way around. Broadcast is always accepted. The unicast may not be able to handle it. The hardware address. Sorry. Okay. What does the client do on receiving the DHCP offer? As I said, can receive multiple offers from multiple servers. Okay. Selects one server as per its policy. Accept its offer. Send a DHCP request to it with the configuration parameters. Okay. This kind of a recheck with the thing like that. This is the parameter that I accept. Because the server may have given it a lot of parameters. I may say I'm accepting these ones. Usually, as I said, will be address, subnet, mask, gateway, DNS, so you'll accept all of them, but there's an option of saying, okay. And the request is broadcast, as we have noted, but I fill up a special server identifier field with the server chosen. Again, that's part of the DHCP message. So all DHCP servers they have offered will receive it, but they are waiting for it, okay. But then they will look at that field to say which is the one that the client has chosen. If it is me, I will do further processing. If it is not me, I will just stop it. And unreserve that IP that I have reserved for the client. And as I said, there is always timeout to start rediscovery if no offer within a certain time. And typically you send, so this is not part of the allocation process, okay. On boot, you typically send a DHCP request just to confirm. Okay. So think of scenario where you've already got a DHCP, everything is working. You shut down your machine, you come back the next day. You had your lease, okay. You had your lease, so everything should be fine. But when you reboot, usually you send that from the DHCP request part of it. You don't need to discover it. You already know who the DHCP server is because you have got your IP parameters. So you don't expect the offer also because you already got it. But you are kind of confirming with the client, the server, whether everything is fine. So you send a DHCP request with the parameters in the fields, and then the server will send you back an ACK again if it is fine, NAC if something is wrong for some reason. Okay? And to renew the lease also, we'll talk about that. So last bullet you kind of, just keep in the background for a second. Server on receiving the DHCP request, if the offer is still valid, will commit the buffer to persistent storage and send a DHCP ACK. Okay. And the configuration will be same as in offer. So, as I said, why will the offer be not valid? Because the server may have timed out already. You don't know what the server's time is. Okay, waiting for you to send the DHCP request, and has given the IP to somebody else. Okay. So, for whatever reason, if the server can no longer give it, okay, is going to send you a DHCP NAK if it can give it still. But then when it sends a DHCP ACK, it's saying that I have given it to you. Earlier was an offer, not a commitment. The earlier one said I can give it. Do you want it? Now you have said you want it. The DHCP ACK is saying fine, I have given it to you, which means it will commit it to persistent storage. Okay. And if unable to satisfy, for I gave you one scenario, you send a DHCP NAK. And if it timeouts for request, as I said, you can make the earlier offered address available to others, which is one reason why you make a DHCP NAK even after getting a DHCP offer. All right. So far so good. Online people, any questions? Is it clear?
Yes, sir.
Okay. Am I audible clearly so far?
Yes, sir.
Okay, good. And then just to complete it, client on receiving DHCP ACK NAK, if NAK, start the entire process again. If ACK, as I said, you make a final check. If no problem, do nothing. If problem, send a DHCP decline. Okay. And if you get a timeout for ACK or NAK, okay, you don't start with DHCP discover altogether, because you already got an offer. Maybe the server is still holding it for you. So send the request to you. You send the DHCP request, you are waiting for an ACK NAK, you send the DHCP request. And as in case of anything, you try a timeout after a few tries. And then if you timeout while receiving this for 3 times Rex or something, then the entire process jump, you start with DHCP discovery. But this is common that any message that you send and you are waiting for a timeout, okay, you send that message again. As I said, client can release an IP before its expiry by DHCP release. And if the client has already got an IP, for example, a static IP, okay, but once other configurations, IP is something that will always come through. Okay? But once other configuration parameters, so you already have a network stack configured, but I want a good file server. I want a time server address. Okay? So you can use another message which we will not do, called DHCP inform, which is basically saying I got the network parameters, but these are the other parameters that I got, additional parameters that I got. Okay. So just to summarize, look at the messages. The basic exchange has discover, client to server, offer, server to client, request, client to server, ACK or NAK, server to client, DHCP decline, client to server. Some of them may be sent, some of them the decline may not be sent. Okay? This is the basic network configuration acquisition process. Other than that, the 2 messages that we heard of, DHCP release, if I want the client to server, if your client wants to release something before its expiry, inform, DHCP inform if it wants additional parameters in the middle. Okay, so far so good, everyone?
Question.
Sure.
So you said that we fix the 268 or the DHCP NAK. But communicate it through the utility message that so can't just keep it at some point and then communicate it via the
See, you have to fix a well-known tool. Because you will just fix 32,176, okay, another machine may be running on that. So the question is that we fix the client UDP port at 68, okay? Can't we just fix it to something, anything, right? Right. Can't we just fix it to something and then communicate to the server? Note that communication to the server is anyway happening. When you are sending the UDP message, In the UDP header, you are putting the source code. So whatever port you use will go to the server. Server will know about them. Well-known ports are used because it's well known. So nobody else is going to conflict with it. Okay. If you use an arbitrary port, another machine which is fully configured running a client may be using that.
So it's for safety, so that
It's not for safety. See, in this case, the DHCP client is kind of acting as a server because the server needs to know something specific about it. It cannot know the IP because the IP has not been configured. So it knows the port. Okay. Okay, any questions from online? Should I move ahead? What's the time? So we'll finish. Okay. So here is the DHCP message format. First of all, this is not in the exam. We don't expect you to remember it, do anything with it. We will not ask you anything about the message format, except for one field that will be relevant for something very important. Okay. So it's a large format, as you see. So this is the entire DHCP message. So this will be encapsulated. So this will be the data of your UDP. Okay. So you'll put a UDP header on top of this, then you'll put an IP header on top of this, then this message will Ethernet data, this will be basic. So this is what the DHCP client on the server is seeing. Request and response is kind of same format, only the fields will differ. Okay. So just I'll go through them, but again we do not expect you to remember any of these fields other than this GIA RDF. So this, where is the use of this field, I am going to discuss next basically. So just to give you kind of this thing. So operation says, as I say, that it can be both a request or a response, and accordingly the value of some of these fields should be interpreted. So operation says, is it a request? That means is one of those discover, DHCP request, DHCP decline, all those messages, something that the client is sending to server, or the response. Okay. H type is saying, right now it's almost always Ethernet, but DHCP can give you IP or address corresponding to different network types. It's not that the entire world has to run on Ethernet. Okay, when specifically when DHCP was, BootP was discovered and was used and so on. Okay. Right now, so it's a type field identifying what is the type of MAC layer interface that we are using. Right now, it will always be Ethernet. HLEN is the header length. Okay, because again you have options which are variable sized, so you need to know what is the length of this entire thing basically. Hops is basically says, see, sometimes your message may get lost. We'll see why. Okay. In a subnet right now, we are right now we are sticking to one subnet on. Everything is happening within one subnet. So I can broadcast anything. But then I will show you something. So idea is if this message has gone through more than certain number of hops, you kind of drop it basically. Okay. So we'll see there can be cases where you can go over networks trying to find a DHCP server but not find it. Then you should not try infinitely forward the packet basically. Okay. And this is what you were talking about. So this is transaction ID. This is what I use to match a request with a response. So someone asked me, so when I send an DHCP discover and I get an offer, everybody gets it, okay? But only the transaction ID will match only for that one client which is sent. The rest of them have not sent first of all anything, but if they have sent also a DHCP discover, so think of a scenario, 3 clients try to connect at the same time. So all 3 of them send the DHCP discover, okay? So the server broadcasts, let's say, the DHCP offer for all 3 of them. So all 3 gets all 3 DHCP offer messages. Now which one is fault? But then the discover message that I send, I put a transaction ID, the server will copy the transaction ID in my message. So I can match it to say, this is my reply to that request. The rest of the 2 will not match, so I will not take it. Okay. Seconds and flags, ignore for the time being. Okay. Time since client began address acquisition renewal. Don't worry about this. Flags, the only thing is one bit indicates if the client can accept broadcast from server or not. The thing that I talked about. Okay. Once again, you don't have to remember any of these fields for your exam. But it's good to study and see how things are when you CIADDR is the client IP address. Okay. So this can be filled in by client in some cases when client knows it IP and can respond to ping. For example, when it is already got an IP, it's trying to renew things. Okay. Otherwise, this field will be all zeros. YI address is also IP address of the client, but it will be filled in by the server after the allocation window. Okay. So I will look at the operation field. If the operation field is 1, the CI address field is valid, YI address field is invalid. If the field is 2, YI ADDR field is valid, CI ADDR is invalid. Okay. SI ADDR is the IP of server to handle the next stage. Forget the handle the next stage. This is where the server will put in the DHCP server IP when it responds back. Well, this will be put in by, so when it's a request, think of the DHCP request. So when I send the DHCP request from the client to the server, and if I have received offers from multiple DHCP servers, then I said that I have a field which says which DHCP server am I accepting. This is the field where the client will put that. So others will look at this field, find that it is not my address, so the client has not accepted my offer. Okay. GIADDR, okay, just remember it's a field. This is what I'm going to talk about in detail in a couple of slides. CHADDR is the client's hardware address. The client will put it in. SNAME is optional DHCP server name to contact. Don't worry about this. File is a relic from the boot thing because, as I said, this came from displaced workstations, but the boot file name was very important. So don't worry about this. So this last two things together is specifies the options have a particular format. What are the parameters that I want? Basically. So on a request, this will be what are the parameters I want. On a response, it will be the values of those parameters filled by the server. Okay. So you see, I have everything. I have the MAC address of the client sent to server. The client can send the DHCP server address to contact. The server can send the DHCP address of itself, basically. Okay. I have the IP address of the client if the client already knows it. Okay. But you see this one saying the IP address of is kind of special. IP is the basic thing you need for network. If you don't have an IP, nothing else matters. So this is not in this configuration parameter. This is kind of separate. Okay. Rest of the things are in the configuration parameter. Is it clear? Once again, you don't need to remember any of these fields other than GIADDR. Okay. Whose use I'm going to talk about. Okay. Is it clear online? Any questions? Anyone? Am I audible?
Yes, sir.
Okay, good. So this I just wanted to show you how will these things just to make sense out of those messages a bit more. And this is a persistent storage I already talked about a little bit. I need a unique ID for a client and I need a unique ID for a lease. Okay. So usually it will be the MAC ID of the client. Okay. The client has an option of specifying something else other than a hardware ID, but typically we don't use that, to the best of my knowledge. Okay. And then for every lease, I will have an ID. This is more for lookup reasons and so on. So ID for lease will be the client's ID, which will be the MAC address, and the assigned network address. So this is the client's unique ID, and this will identify a lease uniquely. So against this, I will have a time which says when does it expire and so on. So DHCP tries to assign the same address to a client every time it requests, before or after lease expires. So it looks at the last lease of clients if they are in storage. So I put something in persistent storage. Okay. So I'm going to keep it for some time, even if the lease has expired or something. If I have stored, if more things come in, I'm going to bump it up. Okay, it's just like a normal, replacement thing and so on. But if the client requests for a lease, I will try to see what is there any particular past lease for the client. Because if that's there, that means basically, I have given you that IP. If that IP is still available, I'll give you the same. No particular reason, but that's how it is. Overridden by requested IP address, this default policy is overridden, but that does not mean that requested IP address will always be given. Okay? It's just a request from the client. These are small details. These are not very important details, but more policy than anything else. And lease renewal, just one slide. You want to start the renewal process before expiry. And these are again all configurable parameters, but by default, a client starts the process of renewal after 50% of the lease time is over. And now it knows the original DHCP server, okay, because it's fully configured. It will contact the original DHCP server. So there is no need to discover or offer, it's already offered. So start from the DHCP request step, okay, and fill up that CIADDR field with current IP already available. And then if the server is still there, everything is fine. Usually it will be, okay. We'll just reply back with the DHCP ACK, and that's it. Okay. It's a simple UDP full file, normal communication because the client is fully configured. Now what happens if you started around 50%, but you did not get a response? Okay. Maybe the original DHCP server is down. Okay. Again, there is a default which is configurable. So 87.5% of lease time. So these are things I don't expect you to mark at all. But you need to remember that you need to renew before expiry. Okay? You need to remember what happens if I'm trying to renew and the original DHCP server is down. Okay? It cannot be that you let the lease expire. Whether it's 75% or 80% or 90% or something is unimportant. It's just these are typical defaults that you will see everywhere. Then you will go back to this, contact any DHCP server for renewal, you broadcast. Okay? You still start from DHCP request. Because lots of time what happens is that I take down one DHCP server for whatever reason. But then I know that it was giving out these 100 IP addresses and the clients had. So what I will do is, I will add those 100 addresses to the DHCP pool of another DHCP server that is existing. So now that DHCP server can give both its original IP address set as well as this 100 IP addresses. So if somebody sends a DHCP request to that, okay, it will still be able to say DHCP active because it has got all the state information of that. Okay. And if it is not able to, it will not say anything. This is a DHCP NAP or not say anything. If it cannot find the offer, then you will run out of lease. Then you will do a DHCP discover, start from this. If the lease runs out, you have to start from DHCP discover. But then you know something, you got an IP earlier, so you will request with that same IP. Okay? But you don't have, once the lease runs out, you are not supposed to use that IP at all. You are once again like, even though you had an IP, everything was configured in your machine will stop using that IP. Basically, it's as if you don't have any IP. Until you get a fresh lease or a fresh IP. Should be the same IP usually, but otherwise. Okay. So there's one topic left regarding the GIADDR field and so on. But is it clear so far? Any questions? Online people, any questions? Clearly audible? Am I clearly audible throughout?
Yes, sir.
Okay, good. Okay, so far we have assumed that I broadcast in the subnet to discover a DHCP server. Okay. Now, if you were implementing systems, your network subnets, your created subnets, we know that every subnet must have a gateway, etc., etc. Okay. what additional things would you have to ensure to make this work, given that what we have discussed about DHCP so far?
Each subnet must have a DHCP.
Right, very good. Okay. So far we have, because we have assumed that it's a broadcast, we have assumed the broadcast will reach at least one DHCP server, which means each subnet must have a DHCP server. Okay. Now think of computer science department. Okay. It is like, so many faculty subnets, student subnet, etc., etc. 5-6 subnets that I know of already. Okay. It's just not possible to configure a DHCP server for each subnet. It's too costly, both in terms of hardware that you have to employ as well as in terms of the administrative cost of maintaining basically. So what can you do basically? So the routers will never send out the limited broadcast address outside the router. That is independent of DHCP. It doesn't matter. Okay? But it can do something. So this is what is called BOOTP DHCP relay. So at least one DHCP server per subnet is too costly if number of subnets is large. So just think, kind of view a thing like that. I have 5 subnets interconnected. Okay, so there are gateways in between and so on. And one of those subnets I put just one DHCP server. Okay. So the client machine and DHCP server can be in different subnets. So now your DHCP discover messages will not be forwarded normally. Limited broadcast is only within the subnet. So what you do is this. Just think with me. You take the first gateway that hits that limited broadcast, which is your subnet gateway. Okay? It cannot broadcast. So just think about a gateway. Remember, a gateway is a router, which means it must have at least 2 network interfaces. It connects networks. So on each network, it must have one network interface. Okay? So just think about kind of a linear chain of networks. One network, one gateway, then another network, another gateway, kind of a linear chain of networks. Okay? Let's say my server is at the rightmost network and my client is at the leftmost network. And I have 5 networks in between. Is the picture clear, online people? Yes, no?
Yes, sir.
Okay, everyone? Because if it is not, let me know, okay? Just think of a long line with nodes in between, and each of those lines is one network with lots of things out there. Okay, and each of those nodes are gateways. Okay? So, what you do is this. The first gateway that it hits will kind of act as the DHCP client. Now, that gateway is fully configured. Okay? It will kind of act as the relay agent for the client on my local. It's fully configured. I will do some more configuration in it. So you know what the DHCP server is. So now it's the unicast communication between that gateway and the DHCP server, because both are fully configured. But you maintain that information that I am doing it on behalf of this client. And when the response comes back, okay, is going to send the response back to the client as if it was the DHCP server. Okay. So what will happen? I can configure routers as DHCP relay agents. I can configure it to give special processing to DHCP packets, even if the destination IP is a broadcast type. So think with me. Okay. Here is what I will do. I will configure the router to act as relay agent, which is to say that router will act as relay agent. Okay. Otherwise, it will just be a normal router. It will just drop the packet. As part of the configuration, I will also configure the DHCP server addresses. This can be more than one. So the gateways that act as the relay agent, okay, will know that these are the DHCP servers, IPs. When the client sends the requests, will set that GIADDR field to 0. Now the client does not know that. But the client thinks it's on the same subnet. Client has no reason to think otherwise. It does not know anything. So we'll start with the client setting that GI-ADDR field to 0. Okay? It hits the first gateway. So it's getting a packet. It knows it is for you. Look at the port. It knows it is for UDP port 67. That is the special processor. Normally the gateways will look at the IP layer. Find the next hop, forward it. If I configure it as a relay agent, we'll also look at the what is the IP packet content. We'll see the port is, sorry, the protocol is UDP. They'll look at that UDP header and see what is the port. See, the port is 67. Which means, and it sees the GI-ADDR field to be 0. Think of the first router it hits. Okay? So this says to the router, this DHCP request, okay, has originated from a client in this subnet. Okay? And it's a request for a DHCP server. Alright? What it will do is this. It will set the GI-ADDR field to 1. Okay? I have written it here. Not the font, sorry. Its own IP. Okay? This is not for routing, because this is happening inside the DHCP message. So it's more binary, 0 or not binary, but it gives the ID so that when it reaches the server will know who has set this field. Okay, I am not drawing, I cannot draw, so I am going a little bit slow, so stop me if you don't understand anything, including online people. Okay? So think of the first router, it got a GI-ADDR field 0. It is configured as a relay agent. Normally routers will only look at the IP layer information, but because it is configured as a relay agent, it look at the port, the protocol field in the IP header, see it is UDP. If it is UDP, look at the port in the UDP header. See it is 67. In the 67, it looks at the GI-ADDR field, find it 0, puts it IP address in there. Okay? And then it will send the UDP packet to each of the DHCP server that you have configured. Okay? That will be a multiple DHCP offers coming, so to say. Okay? The source IP will put the relay agent side, because it's now acting as the kind of the DHCP client. Destination IP, the DHCP server IP. Source port will be 68 because it's acting as the client. Destination port will be 67. And now your packet has perfect network information. Everything filled up properly. There's a configured machine that is active. It will be forwarded normally. Okay. Any other relay agent that are configured, because all the other subnets will have to configure the relay agent also. Okay. So now think it has hit the second router after crossing the second network. Okay. The second network's router, now first thing it does, again the same thing. Because it is configured as a relay agent, it looks at the protocol field of IP, finds its UDP, looks at the protocol, sorry, port field 567. If one of these does not match, it drops it. Not drops it, sorry, forwards it normally. Okay. If it is this, so it knows it's a relay packet. It looks at the GI-ADDR field, finds that it is already has an IP address. If it already it does not change it. It will just forward it. If it is 0, that means it originated my subnet. Nobody is acting as a relay agent on the behalf of the client. So I will act as a relay agent. I will put my IP. If it is anything else, I will not put that. Clear? So we go on like this. You reach the DHCP server. Okay. When the DHCP servers visit the packet, checks the GI-ADDR field. So it creates the responses as offer, request, etc., whatever. Okay, depending on what the message is. But then it takes the GI-ADDR field. If the field is 0, it's the earlier case we discussed. The client and server on the same subnet. So I look at the broadcast flag, etc., and send it like that. Okay. If it is non-zero, it will send the response okay, to the relay agent. So your source IP will be DHCP server IP, destination IP will be relay agent IP. I know it from the GIRDR field. Source code will be 67, destination code will be 60. So now your communication is happening with two perfectly configured, already configured machines. And when it comes to the relay agent, okay, it knows I am the relay agent because that's why it has received the packet. That's the destination IP. Okay, looks at the UDP port 68. That means the response to that. Now it knows the client must be on my same subnet. That's why I am the relay. So it's just going to again send it normally. Is it clear? Online? Any questions? Is it clear?
Yes, sir.
Okay, everyone could hear properly. Anything I have to repeat?
No, sir.
Okay. Okay. So DHCP offer is just an example I've taken. It's for all messages because eventually it has to go. Basically, once you are configured, then it doesn't really matter. So that's the only other interesting thing. So that gets done with DHCP. So you need to remember the basic exchanges, some basic information like how is this, at least the discover how is it sent. Okay. As I said, the server to client DHCP offer I've kept a little bit vague, but you get the essence basically. Okay. And after that is kind of vague. But remember, until you have got the ACK from the server back, you are not allowed to use the IP for any communication because it's not complete. Okay. So remember the basic message transfer. Remember this thing about relay agent. The header format is more for your information and understanding. Will not ask you anything specific to any field except for the GIRDR. If you forget the name of GIRDR, I don't mind. Okay, but you need to remember that there is a field which will indicate that there is a relay agent. That the relay agent will put it in that field or something. Okay? If I ask you how does the relay agent work and so on, basically. And for each of those messages, remember they are all UDP messages. So whenever you see any protocol with UDP message or any protocol per se, okay, you always think about at every step, what if the message is lost? What if the message is deleted? When you do TCP oriented things, at the application layer, TCP gives you a guarantee. So you don't need to worry about it. But the UDP pushes the responsibility of retransmission to the application. So you always should ask when you are using UDP, what if this message fails? What should the application do? So let me end with a question. So is TCP absolutely reliable? Will TCP always guarantee that the message or you send a message, let's say with 100 bytes, fine, 100 bytes can be broken up, etc., etc. Okay, that will always reach the other. What do you think? Anybody offline, online?
Not necessary.
Okay, why not?
So like
First of all, there is a non-zero probability that some router will always try. A simple way to look at it: what if your line is cut? Okay. So there are other things out there. So TCP usually tries for a certain, when you do the retransmissions and all, you usually try for a certain amount of time. So I think I forgot the default number, it's 16 retransmissions or something like that. I may be wrong a little bit here. If it does not, it gives up. Close the connection. But then that's an extreme case, basically. If the line is cut, nobody can do anything anyways. But then your connection will close. That's as far as I remember. If it drops, if it cannot transmit beyond that thing, it will stop it and it will close the connection. So we'll get an indication that something has not gone. Okay, so we are done with basic, what I would say, the network stack management kind of protocols, support protocols, essential protocols that make the network work. Okay. The only thing left in our course is doing one application layer protocol. We'll give you a small idea about HTTP. I'm not very excited about it. It's more for completeness, as I said, like application layer protocols are all different depending on their needs. But it's still good to see one example of one thing that we use. And HTTP is also huge, but we will give you a sample of it basically. And so that we will finish on Monday. And rest of the time, it's your choice. It will be optional classes, but then I will do it only if I see sufficient interest. So I have 6 people sitting in offline class in front of me. Okay. So this is the other interesting thing. So we'll discuss that. So if I have sufficient interest, then I like to talk an hour each on couple of things. You will not understand those fully, but that is more to stir your interest if you are interested. Okay? One is I'm going to talk a little bit about the physical infrastructure. The switches going to bigger switches go to bigger switches and so on. But then typically what happens is that you can trace that even if you know to, let's say, CIC's router, or let's say then you say ISP's router. Okay? But then what? Fine, BSNL, I take connection from BSNL, so BSNL will connect a line with me. So my router's one outgoing link will connect to some BSNL router, But then what? If I take connection from BSNL and you take connection from Airtel, how does your data come to me? Okay, what is the physical infrastructure there, and what is the little bit about what is the internet routing architecture beyond this thing? Okay. Just the idea basically. That's one thing. The other 1 hour I would like to talk about is, again, you will not understand everything, but you will know some terminology and get a basic idea about. So when you do www.google.com, you send a search request or something. Okay? Any kind of large, very busy website and so on, what happens? Basically. So fine, it's TCP and all these things are there, but first of all, how does your, basically this question, how does your request get routed to the data center? Because Google has so many data centers. Google is just an example. Many of them has many data centers. They're hosted in clouds in many places for other people. Basically, Google has its own data centers and so on. How do you know which data center your request should go to so that everybody runs? Basically, because so far what we have learned is we have seen this IP, this is the next one. Okay, so if I fix things like that, then certain things coming from certain networks going to certain network will always follow a certain path, assuming nothing fails and so on. But then that's very traffic agnostic. If there's too much load on from one region, for example, okay, you don't want to, everything will get blocked. Something will get blocked because at the edge, if too much traffic comes from a hostel, the hostel switch will get blocked. Nothing we can do about it. But then, it's a little vague. But if you're interested, I can talk about that a little bit. But I need at least 10, 15, 20 people interested in that. Basically. And that can be an offline class or that can be an online class. So discuss among yourselves, both offline and online. My voluntary class representative is here, poor guy. Okay. So let me know and we'll do that. Otherwise, we have 1 hour of class on next Monday. And I'll be available for the other 1 hour to answer your questions and so on. Okay, any questions from online people? Offline people I can see. Any questions you have? So how many people do I have online people? I have 13. Good number.
Okay, so you were going to
Yes, but I got some. So online people are feeling a bit left out. Okay, and no, rightfully so. They have reason to feel left out. Okay, and comparison with OS class came up. But what they are doing in OS, I know by both of them. They are excellent teachers. Okay, I'm very proud of them. They are both my students. Okay, but what they are doing now is an initial plan that you make. Let me start on the record. Okay, this does not need to be recorded. No. I'm saying nice things about, not because of